This is a brief recording on elasticity of demand. We're going to talk about an arbitrary demand function. Suppose we have a demand function for some good, Q equals a function of price. And we want to find what economists call the elasticity of demand. Elasticity of demand is defined as the percentage change in the quantity demanded, the percent change in Q, divided by the percent change in price, or P. And the way that was ordinarily computed, at least in a principles of economics class, was by defining something called the arc elasticity of demand, where you had two distinct points on the demand curve and wanted to compute the elasticity between them. And in order to do that, you computed the change in quantity, divided it by some base quantity. In order to turn it into a percent, you had to multiply by 100. And then for the prices between those 2 points, you computed the change in price, divided it by the base price, which was usually the average price, again, times 100 to change that into a percentage change. And whatever that was, that's the elasticity of demand. Now we can see that these hundreds that appear in the numerator and the denominator can be canceled out, and so we can write the elasticity of demand without including those hundreds. It's a change in Q divided by Q over a change in P divided by P. Now, in some cases, we don't have two different price points along a demand curve, but we know that the equation of the demand curve itself, and we're interested in finding what is called the elasticity at a point, or point elasticity of demand. Point elasticity. And now that we're well into calculus, we know that we can look at this expression and see that in terms of instantaneous or very small changes, the point elasticity of demand is dq over q divided by dp over p. And from what we learned about total differentials, we know that we can do some algebra on these so that the point elasticity of demand is dq dp times p over q. So let's take an example. Here is a straight line demand curve. A linear demand curve says that quantity is equal to 300 minus 6p. We can try and draw that demand curve up here. Following the usual convention in economics, we put the price on the vertical axis and the quantity on the horizontal axis. And we can see that this has got to be the point 50, and we draw down here a straight line, and this intercept will be at the point 300. So if they were giving this away, people would want 300. If they were charging $50 per unit for this particular good, people wouldn't want to buy any of it. And the question we want to answer is, what's the elasticity of demand at any point along this demand curve? Well, we recognize this as the derivative of the demand curve based on Q. And once we find that derivative, we just have to multiply that times the ratio of P to Q, and we'll have a formula for the elasticity of demand. So why don't we do that? dq dp is equal to minus 6, of course, so that the elasticity of demand is equal to minus 6 times P over Q, but we know that Q is 300 minus 6p. So here is our elasticity. Now we can ask, for example, what if the price is equal to $10 per unit? We want to know what the elasticity of demand is in that case. So what we can do is use our formula for elasticity here, just substituting in 10 for price, so that the elasticity of demand is equal to minus 6 times 10 divided by 300 minus 6 times 10. And if you do some arithmetic on that, you'll see that the result is minus 0.25. And we remember that remember first that it's minus because demand curves are negatively sloped, but the fact that it's a decimal less than 1 in absolute value means that this is what we would call inelastic demand. And so when price is 10, you could find the corresponding quantity, and we know that elasticity there is minus 0.25. Proceeding on, we can take one more example. Suppose price instead is 40. What's elasticity of demand? Well, if price is 40, then elasticity of demand is going to be minus 6 times 40 with a minus sign, which is 240 from over here. And we have 300 minus 6 times 40, which is 60. So that the elasticity of demand is minus 4, and we would say that that's elastic. So here, at a price of 40, we have a corresponding quantity, and demand, elasticity of demand here is minus 4. And that means demand is elastic. Well, the lesson here is that while the slope of a straight line is a constant, elasticity is not constant. Demand curves that are linear start off at very high prices where the demand curve is elastic, and then they eventually become inelastic. Down here, when the price was 10, the elasticity of demand was actually minus 0.25. Somewhere along in here, then, it looks like the elasticity of demand at some point is going to be minus 1. And in the next video, if you care to look at it, we'll show you how to find the price and quantity at which the elasticity of demand is 1.